a particular user is trying to operate with the system, then whether he is able to understand that there are multiple sites existing, or he is able to understand there are multiple places the data of employee is available, is it is a single central database or not. So this understanding is what transparency means. So if I say I have a fully transparent system, which means that the user will not be aware about what is the inner level deployment details, which means whether it is multiple site, multiple databases, or is it a single site, multiple tables, or is it a single database and single site mechanism, which means a central database. So whether it is distributed or not, whether it is a centralized one or not, that information will not be there. User will always feel that he has a database dedicated for his purpose and then he is accessing it. So when you execute a query, say select star from employee where some date of birth is before this. So if that is what you are trying to figure out, then you don't know whether there are distribution happen. So whether this employee table what you are referring is in single place or multiple places. Like say it can be horizontally distributed. Horizontally fragmented distributions is possible, right? What you mean by horizontal fragmentation? Which means I have certain set of records in one place and certain set of records in another place. I am not dividing my table. I am dividing the contents of the table. So the table structure or the schema remains the same. If that is the way I am stored it, then this particular query needs to be executed in two different locations and the results needs to be combined back and then given to you. So from your side, when you look into it, you assume that there is a single database and there is a single table called employee. I am accessing it. So this way of hiding those inner implementation details to you is what transparency is going to discuss. So different levels of transparency we have discussed. I mean, like different types of transparency we initially spoke. There are 5 different types. We spoke about distribution transparency, transaction transparency, failure transparency, performance transparency, and then we have, sorry, yeah, heterogeneity transparency. So distribution transparency, there is 3 different levels are there. The most strongest one is the fragmentation transparency, and the most weakest one or the most loosely coupled one is local mapping transparency. So assume a scenario that I have 2 different locations and my table is, or not 2, 3 different locations, and my table employee is split into 3 different separate tables, E1, E2, E3, and kept in different location. So when I am referring to access a data, if I'm specifying that which particular node the data should be looked for and which particular table it should be looked for, if that is what I'm specifying, then I will say that is a local mapping transparency. That means my distribution system has got only local mapping transparency, which means that user will know that it is a distributed system and it is multiple sites are there and multiple tables are there. Okay. Now location transparency means I am mentioning only about the fragment, but not the location. I am not saying that whether I have kept it in node 1 or node 2 or node 3, which site I am not mentioning, but I am saying that E1 is the table I have to access. Even if you access, then only you will get half information. E2, if you access, you will get another set of information, and then E3 and combine thought. So in that case, I don't know whether E1, E2, E3 are in the same site or in different site, but I know that it is not single table, it is 3 different tables. Okay, so if that's the way you are going to design your structure, then you will say your distribution system is having only location transparency. Location transparency means information about location is being kept hidden from the user. On the other hand, the strongest level is fragmentation transparency, which means that user will not know whether it is stored in different locations or whether it is stored in different tables, whether the employee table is a collection of multiple tables, E1, E2, E3, stored at different locations, N1, N2, N3. That information you will not come to know if you are working with fragmentation transparency. So ideally speaking, achieving fragmentation transparency is the best thing for a distribution system. A fully distributed database system would try to achieve fragmentation transparency, but there can be several reasons why we go down in the line and then say we will have location transparency or local mapping transparency, maybe for implementations, maybe for ease of access or scaling the levels. Different reasons we go with different types of transparency. So that's about distribution transparency. We'll come to transaction transparency. Now, whenever we discuss about a transaction in distributed database, understand that, say, previously when you were trying to execute a query, say you remember your DBMS sessions in the lab, how we were doing it. We have a client side UI interface where, I mean UI, where you will be typing your query and your database in the same machine, it gets executed and you get the result. But actually there is two different units involved in that process. One is referred as a transaction processing and the other one is referred as a data processing. Okay, now that in a centralized database where you are trying to work on a standalone machine, this doesn't make much sense. But when you talk about a web-based application or a distributed database based application, you will have to understand that these two entities need not to be in the same machine, rather it can be in different machines. Okay, so if I'm having a centralized database, these two entities will be there in the same machine. But if I'm having a distributed architecture, a very simple distributed architecture also, you may need to keep these data processing unit as well as transaction processing units in two separate places. Okay, so now whenever we talk about transaction, we have to understand that there can be different levels of transactions or different types of transactions is possible. Okay, so before that, what exactly the definition of transaction and transparency is? It ensures that the transactions will be completed only if all the database sites involved in the transactions complete their part of execution. Okay, now say previously we discussed about employee table is divided into E1, E2, E3 and stored into three different nodes. I mean three different sites, New York or some other different cities of US. And that is how you are accessing it. And you are sitting here and then probably updating some data for them. So in that case, we have discussed about I mean, like you have studied transaction processing, right? What do you mean by a transaction? Is it a single query execution is a transaction? What is your understanding about transaction, students? Anyone?
Sir, a logical unit like a multiple queries with a start and end.
Okay, I mean, whenever you want to perform an action, it may not sometimes limit to one single query execution. So you may sometimes will require multiple queries to be executed. So a transaction is bundling them together, saying that logically this belongs to one single component. Transfer of a fund. Yeah, so transfer of a fund in a bank, if you are talking, then multiple executions you may require to do it, multiple SQL transactions. Debit and credit. Yeah, you need to debit from your account and then credit to the receiver's account and then update the logs and other things. So whole of those becomes a transaction. Now, in case of a distributed database, whenever you say a transactions will be completed only if all the involving entities completes their individual transactions. Say same example what we have previously seen, employee. I am going to update saying that all the employees say designations I'm changing. Say previously we were using some designation saying that they are area managers or something. Now company decided that there is no area manager concepts, rather we will have division heads or something. So some different term they are going to use it. So they said we are changing the entire hierarchies. So your new designations will be this. Now, this area managers need not necessary that they will be in one single table like E1 or E2 or E3. It can be spread in all the three different tables, spread across different locations. So when I say that update employee table set designation is equal to this, where previous designation is equal to something. So that is the query when I try to execute. That becomes a transactions now. Okay. Now that transaction will complete only if E1 part gets completed, E2 part gets completed, E3 part gets completed. So now E1, E2, E3 are located in different locations. So there can be transaction processing unit which is sending this query saying that I want to execute this transaction. And you will have three different places, databases, and three different data processing units will be there attached to it. Those are the one which is making sure that this transaction gets executed there and the data gets updated. Okay, so now what happens is the data processing unit at site 1 where E1 table is there, it makes sure that this query, whatever it matters, that gets updated. So it may be sometimes only one record you may need to update in E1 table, but that is done. Then the data processing unit at E2 will make sure that whatever the query says, which all fields which going to which all records which will affect because of this reason, that gets updated. E3 also same thing. Now these data processing units should communicate back to the transaction processing at the remote place saying that we have completed it. Then the transaction processing unit will say that the transaction is completed. So this part, once it's done, then from the user perspective, a transaction is initiated, transaction is completed without any failures. So which means that it is as good as executing it on a centralized database machine. So we will say, I didn't know about multiple sites are there or multiple fragments are there. I have started a transactions, it has executed properly. So transaction transparency is actually implemented this way. Like three different data processing units were there here. All of them executed that and then updated the status saying that it's been done. Then a common message goes to the user saying that your transaction is completed. So we were talking about different types of what you call transactions. So one of the type is referred as a remote request. A remote request in the sense you wanted to fetch some data. A request means that only, right? I wanted to fetch some data from the data storage or the database. So a remote request, in that case, I have now two different machines physically. In one machine, my transaction processing is happening. And in one machine, I have my database attached and there is a data processing unit. Now, my transaction processing says that select star from customer where customer state is equal to AL. So that is the query I wanted to execute. Now, in case of a remote request, the query will go from this transaction processing unit to the uh, machine or site where exactly the database is attached, the data processing unit is there, to that machine over the network and gets executed and fetch the data what you require back to transaction processing unit at the site which has made the request. So that is referred as a remote request. So whenever you talk about a remote request, understand that your transaction processing is different, data processing it at different sites. Okay, but we are not saying whether it is a centralized database or a distributed database. It is not necessary to have a fully distributed architecture there. You can have only one single database attached to a site and the other site will be only doing transaction processing. That way also you can design a distributed architecture. So in that case, we are dividing that job into two different places. One place will trigger the transaction, other place will execute it, update the data, and then reports back to the transaction processing. Now, we spoke about remote request. When we say request, it is about fetching some data. Now, a remote transaction, when I say, it probably will be about updating the data. So, update product, set product quantity equal to product quantity minus 1, where product number equal to something, insert invoice, some two different transactions are there, assume that. Okay, now when you look into those two different transactions, the first transaction, sorry, two different SQL queries. The first query is dealing with product table and the second query is dealing with invoice table. Okay, now the way how I have stored them is into two different databases. Okay, I have an invoice database, I have a product database, but probably both of them is stored in the same site. That means we have done a lab exercise where you have two different databases, test1 and test2, and you try to connect it into your same PHP application and then you have retrieved data and then displayed it, right? So somewhat similar. Instead of retrieving, I'm going to update. Okay, so I wanted, see what we have done is the employee table, we have kept it as two different places. There is an employee ID and employee name at one database. Employee ID and employee salary was in another place. And we combined it and then retrieved the information. Now here what happens is it is updating. Both places probably I have to update something. So what happens is the transaction processing unit at site A has sent out a request saying that this is the transaction I have to execute. Now in this case, you have only one data processing unit because the entire database or multiple databases is situating in a single site, or I can say a single machine. Okay, as in our previous exam, I mean like as in our lab exercise case, both are in the same server machine and it's but two different databases. Now the data processing unit will understand that this transactions involves updating tables of two different databases. Then it communicates to both those databases and then updating it. Once that update is over, it communicates back that the update is over. We have committed the data in both the databases. Both the databases are in the updated state. That information comes back to transaction processing unit at site A. Then the transaction completes. Here also you are achieving transaction transparency because the user who is going to work on the front end application, which is talking to the transaction processing, will never come to know that there is a database which is situated in another site, and in that site it is multiple databases. That information is not known to me. That means fragmentations I am not sure, I'm not knowing, as well as I'm not knowing about the site. So this is also another level of what you call transaction transparency. Now I can relate this to distribution transparency. What type of distribution transparency is this? I don't know about node, I don't know about fragmentation. Then what is the type of transparency it is? Distribution transparency it is. There are three different types. It can be fragment transparency, it can be location transparency, and it can be local mapping transparency. So which one is this particular type? Hello? Anyone is there?
Yes, sir. Yes, sir. Here, basically, the databases are like two different sites, no, sir? Or like, is it a
No,
same
no,
site?
it's only, I mean, like the database is, yes, in two different sites, but the data stored only at single location in two
Yes.
different databases. At site B only I have the data stored, but in two different databases.
Okay, sir.
So here fragmentation might have been done, but I'm not sure whether fragments are there or not, whether different databases there or not, whether the entire data is stored in a remote site or not. None of those informations I am passing to the user. User given a transaction, it's been executed and completed the commit operation. So in that case, is it fragment level transparency or location level transparency?
Fragments.
Sir,
Fragment level transparency. Yes. So
have
this
the
is,
databases,
yeah,
no,
tell
sir?
me.
We have two separate fragments, no, sir? Like two different databases.
I mean, fragmentations, when I say, need not necessary that you are talking about fragmenting a table into multiple places. Basically, data fragmentations indicates that your data is split in into different tables and different databases. So in our case, what we have done is we have two different databases now operating. The invoice is a separate database, or I mean, invoice table is contained in a separate database, and product table is stored in a different database. Like how we have, I mean, we in our lab exercises, what we have done is we have the same table employee, but split vertically and stored in two different databases, test and test one, or test one or test two. Here what happens is I have not done vertical splitting, rather separate two different tables, invoice table and product table, but kept in two different databases. Okay, so I can say fragment information is not known and the location information is not known. So in that case, it is when you look into distribution transparency approach, I mean like perspective, it is fragment level transparency. But what we are trying to talk about is here with respect to transaction. So from the point of a transaction execution, the user will never come to know that there is a remote site called site B, and you have two different databases, invoice and product. So that way it is achieving transaction transparency. Now, next one is a distributed transaction. Okay. Now, when we say a request and transaction, there is a difference. Request is always associated with select operation. You are trying to fetch some data. Transactions, when you say, it can be involving all your update, insert commands and other things. Okay. So now what happens is your transaction is something like updating product, then inserting one entry into invoice and updating customer. Okay. When you look into your distributed database, you identify that there are three sites totally involved: site A, site B, and site C. That means three different physical machines located in three different locations connected over a network. Site B and site C basically has got data processing units and databases associated with it. Site A is a transaction processing. This is an example of a proper distributed database. Okay. Now your front end application is talking to your transaction processing unit at site A. And it said, I wanted to execute this transaction. And the transaction processing unit has made the transaction saying that product needs to be updated, customer needs to be updated, and invoice needs to have some more entries into it. Okay. Now that transaction request, previously it was sending into only one site, site B, because we had only one site. But now what happens is this particular transaction involves three different tables which belongs to three different databases. Customer table belongs to another database. Invoice table belongs to a different database at site C, and product belongs to a different database at site C. So in that case, both site B and site C needs to be contacted to complete this transaction. So over the network, your transaction request has gone to site B and site C. Same transaction will go to site B, same transaction request will go to site C also. Site B will look into the transaction. It identifies that only one of the table is relevant to him, that is customer table. Whereas site C will understand that there is product and invoice it is talking about, and both those tables belongs to databases available at site C. So what site B will do is take out the update customer, set customer balance is equal to customer balance plus 120, where customer number is equal to 100. That single query it will take, find out which database it is talking about, which table it is talking about, update that, and sends out a commit operation for that part. That means site B will say that I have completed my operation. Okay. Transaction processing unit at the site A will receive one information from site B. Then site C will look into the transaction. It will identify that there are product and invoice table needs to be updated, and those belongs to two different databases. So query will be executed in both these databases, and successfully, upon successful completion, it will send out an information back to site A saying that I have completed the transaction successfully. Now the transaction processing unit at site A will now ensure that site B and site C has given them successful message. Then it will send out information to site B and site C saying that commit those operations. And upon receiving successful commit operation message, site A transaction processing unit will update the front end interface to the user that your transaction is completed. Okay. So in a distributed transaction, the transaction process, yes, tell me.
And sir, like what if the updates are dependent? Like updates. Here, the side B is getting the total query, and then it is executing the last query first because it is having the database of customer. And only like in your example, you said C is executing the the first and second queries. So basically, yes. The the query is getting executed first, and then the order can be changed. What if we have to execute in a particular order, then it won't be satisfied, no, sir. Like tables can be dependent also.
Tables can be dependent in the sense, if you when you are fragmenting and storing in different location, at that point of time the database administrator needs to look into this. So when you are defining your schema, you might have looked into your table architecture and then design that it should be there should not be any conflict, and even if there is a dependency, either you keep those two tables in the same databases in a single site. I mean, this distribution into customer invoice and product is done in such a way that I will not have a transaction which is going to I cannot execute it independently in these different sites separately. If that is the case, I may not be able to achieve distribution. Okay, so when I'm designing my distributed database schema, I need to ensure that there is no such dependency is going to have, or if my application requires dependency, then I need to ensure that those database tables are kept at the same site, same database, so that when you execute the query, the dependency will be handled. Other way, if you designed your distributed system, then you cannot run that application. Okay.
Yes, sir. Thank you, sir.
So it's all depends upon how you design your distributed database. I mean, it's just an option, like you have different sites and different DBMS available for you. But how you keep those data, you will keep two things in mind. One, you need to have always minimal interactions with these. Okay, because if you say maximum interactions, you need to always understand that these communications happens through a network. Okay, now the amount of time it takes to execute a query in a single central database, if I am talking, it's in happening in nanoseconds or probably in milliseconds, then the communication delay happens over a network is always in milliseconds or seconds. So what happens is, when I have multiple sites and my query needs to be executed, the user will always feel a delay. Why? Because your query first needs to be sent into multiple locations and gets executed. Commit has to come back. Successful commit, if I get from all the different sites, then only transaction processing unit can finish and then say that your query is updated properly. So which means that there can be multiple communications involving passing through the network. So obviously you will have more time required to complete that. So user will feel it. So if I wanted to give user a better experience of the application, then I need to make sure that his transactions are executed with minimum interactions between sites. I will try to design my distributed database in such a way that most of those transactions what I'm seeing should be able to execute in individual sites independently, so that less communication or less interactions between different sites is only required. But at the same point of time, I have limitations of keeping this entire data in a single central database. So that's why I'm keeping them separately. I think we spoke, I mean, like ma'am spoke about why distributed databases actually started evolving, like what was the requirement and all sort of things. So it's not that we wanted to do distribution, so we designed it. It's that data was already available at different locations and different databases. We wanted to merge them together and then use it. So we designed a distributed database. That's how the evolution happened. Okay. So while designing, you need to take care that minimum interactions or minimum dependency is kept among these different tables what you are talking about. Okay.
So this also means like we cannot have same databases in the, like we cannot have customer table again inside Sina, sir. How, no, sir?
You can always have it. I mean, that's what I'm saying, that you cannot have it is not a statement. It's if you say there is a customer table available in site C also, what is the challenge going to happen in executing this query? At site B, update customer, set customer balance equal to customer balance plus 120, where customer number is equal to 100 will execute. Okay. Now, if you are saying that site B and site C is having a customer table with same data, are you going to say that way?
No, sir. No, sir. Like same
It is
table name.
obviously either horizontally or vertically splitted, right?
Yes, sir.
Assume we have done horizontal fragmentation. If it is horizontal fragmentation, this customer number 100 will be available in only one place, either at site B or site C. So what happens is site B will identify that out of this transaction, update customer query is the only one which it has to execute. So it will execute. So assume that there is no customer with a customer number 100. So that query will return 0, saying that there is no records I could update. Now goes to site C. Site C will understand that update product, insert into invoice and update customer. All the three has to be executed because all the three tables are there also. So it will execute. Now we look into update customer query specifically. That query will return saying that one record is updated because the customer with the customer number 100 is available in the site C table. So in that case, that will get updated. So in that also there is no dependency going to happen. But suppose if you say that your tables are vertically fragmented, then there is a difficulty in the sense you need to make sure that site B is also updated, site C is also updated parallelly, then only the operations can be completed. So in that case, if it is vertically fragmented mechanism, transaction processing will come to means will know about it because the distributed directory what the distributed database stores will say that the customer table is not horizontally fragmented, rather it is vertically fragmented. So your query needs to be updated in two different sites. So when the commit operations comes from these people, it will check whether site B and site C both have done transactions on customer or not. If both have done it, then we will say transaction is completed. So it always depends upon how you have kept your data. Okay.
Sir, like we will be getting an attribute error. No, sir. Suppose we don't have, we are vertically splitting and then take our employee table itself, like employee ID and employee name in one employee table, and then another one has employee ID and salary, and we are performing an update operation in salary. So, like the side B also will be executing that query, and then side C also is executing that query. In that case, we will be getting an attribute error, no, sir, or
Yeah, the
will.
saying that such an attribute is not available, right?
Yes, sir.
Okay. Now, for understanding purpose, I have taken out these queries as such and then saying that at side B, I will be executing this query as such. But don't expect it that way. Then in that case, you don't require so much of brilliancy in designing a distributed database. The data processing units also needs to know what is the distributed data directory you have. Okay, DDD. So the distributed data directory information should be known to all the data processing units also. Then only they will be execute a query successfully. So when a transaction comes like this, the data processing unit will first analyze all the queries in that, and whichever queries is relevant to that particular data processing site will be taken and then will be further looked into it, finding out whether its distribution structure is being followed or not. So the example what you told, if I have vertically split and customer number belongs to only one particular part and it is not in the other table, then as you said, there can be an error coming up. But only if you execute the query as such. But if you modify the query saying that I have only two fields, salary and ID, and based on ID, I am going to update salary. So if that is the case, in the name, in the table where name is kept, I will modify it in a different way. I will not have, I mean, like my query needs to be split into two parts. First part will be talking about updating salary. Second part, I will find out whether any updation on name is required. It is not required. Then the query itself will not be executing in the other side. Only if you execute the full query, then only you will be getting an error saying that such an attribute is not available here. So this is an error in the query kind of things. So the data processing unit also will know what is the distribution structure, what attributes are there in each table here, and whether this full query or you require to split and then only consider those attributes which are relevant to it. But again, all these things possible if these attributes are not dependent. If the attributes are dependent and your query what is coming is going to be joining or combining multiple attributes, then this way of distribution will not work. It will fail. Okay, so it's all depends upon your initial part of designing your distributed database. So you need to have a clear understanding about what type of application I'm going to use, what are the different transactions possible, and then distribute your data. Okay.
So like how will it even distinguish? Because it will go through, like it will be like parsing every word, and whenever it is encountering an attribute which is not found in the databases it has, it will be like this query is not for my site. Will it be like that, sir? Like here,
Yes.
we're not even fragmenting, no, sir. We are not even mentioning about the site or anything. It's just the table name we have.
But
Okay.
at the same point of time, the data processing unit should know what are the attributes you are talking about. So each table, what attributes it has got. So the schema information of all the tables will be available with each data processing unit. So when the query comes, now this query is executed as a C function in the database. This query, what you are talking here, no, like say insert into invoice something, its actual execution happens when corresponding C function is or C routine is being invoked. Okay, so in that you are basically passing each attribute as an argument to that function, a parameter to that function. So it will easily be able to figure out that this particular argument is not there for this particular table. So you can modify your routine accordingly and then execute it. So that's how it happens.
Yes, sir.
So
It's like method overloading in
yes,
oops. Like,
yes, yes, yes. You need to have that. So when you talk about a distributed database, design is itself is a complicated process. So think of the complexity of the distributed database code. I mean the software, how some people might have developed, because you need to understand all the different combinations possible. If you talk about a table with 10 attributes, somebody can split horizontally, somebody can split vertically, and vertically if you are splitting, the maximum number of verticals it is possible is 10, because there are 10 attributes. I can keep each of those attributes separately in different places. That is also possible. That's the maximum extreme case. So then how my query should be executed in such cases? I need to look into all these scenarios and then write my C routines accordingly, so that when a query comes, I should be able to execute it. So that's the challenge in having a distributed database. That's why you are not finding so many commercial applications or so many commercially successful distributed databases. Rather, you will find, see, Oracle is able to do it. They are the largest in this business, so they did it. But otherwise, you will not find many open source or free distributed databases. The only, I mean, like an example which goes the other way is MySQL. MySQL has got something called MySQL cluster, which uses a distributed architecture, which is free and open source. Only thing is you have to register with MySQL. Once you register and you are a registered user with MySQL, no money is required. But once you do that, you will be given access to MySQL cluster. So that much, I mean, behind the scene task is involved in developing a distributed database as well as executing the design part of distributed databases. Okay, we'll move on to the next transaction. So the next one is a distributed request. So what we have seen previously is more complicated distributed transaction. A distributed request is little more easier because you are not going to update any table, rather you are only fetching data from the table. Here also the same problem. A single SQL statement reference data located at several different local or remote DP sites. Okay, so select customer number, invoice total. From customer and invoice were some features you need to look for. So customer is in one data site, invoice in another site, and invoice is in a site where there are multiple. databases also. So when this query comes, the query goes to site B as well as site C. Site B understands that it is asking for customer information. So customer informations and relevant attributes related to that will be fetched. Site C will also fetch information related to invoice, combines together at transaction processing unit at site A, and then provides the output finally to the end user. Okay, little more easier compared to the previous one, because there your query needs to be modified and other things. Here it will be little more easier. And this is another distributed request, because previous one we had two different tables. Okay, now this example is we have tables split horizontally or vertically. That means fragmentation is done on the same table and kept in two different locations. So if the query is select star from customer, where customer balance is greater than 1250, so in that case I need to do the same thing at C1 and I need to do the same thing at C2 and get the data and combine it, assuming that C1 and C2 are horizontally fragmented pieces of customer table. If it is vertical, again more complications will come. Okay, so that's another transaction. Now we were talking about transactions. So along with transactions, another topic what we have discussed was concurrency control. Okay, so in transactions, concurrency control means when multiple transactions are happening, how you are making sure that inconsistencies are not happening or transactions end up in deadlock situations. Oh, it's already 9:20 almost. So we will talk about this distributed concurrency control in the next class and then finish it off. Okay. Thank you.
Thank you, sir.
Guys, I am saying that class is over. At least now switch on the mic and then say thank you.